Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. So today we'll be discussing the concept on moment of a force. So basically, moment of a force, it is a tendency to cause a body to rotate about a particular point. So this is the tendency. It is different from a body which is moving or translating along the direction of the force. So whenever a force is applied on a body, so when a body moves along the direction of the force, so then that it can't be claimed as a moment. So that is a basic difference. So whenever if the body wants to develop a moment, the force must act upon the body such that it would have a turning effect. So this always occurs every time when the force is applied so that it does not pass through the centroid of a body. Whenever the force is passing through the centroid of the body, then the moment will not develop. So whenever the force is passing apart from the centroid of the body, means the line of action of the force and centroidal axis, if it is not coinciding with each other, then there will be existence of the moment. So this is the basic fundamental concept of a moment. You can just observe in the sketch here. So the moment is developed when for a cantilever beam I have just taken here. So the force is acting on at the free end, and A is the distance from the force as well as the fixed support. So you can just observe as the force is acting, so there will be a deformation. So this deformation causes the slope in the fixed beam, fixed support. So that slope is called as the turning effect, and that turning effect is nothing but a moment. So this is the physical meaning of a moment of a force. Next, coming on to the meaning of a moment in mechanics. So as we know that moment is producing the turning effect. How the moment is producing the turning effect? In the means of action of a force. So whenever the force is acting apart from the centroidal axis, then the moment will be developed. So it is nothing but the product of force and the momentum. So when the momentum is the particular perpendicular distance, it is a perpendicular distance from the line of action of force and the reference point for the calculation of the moment. So you just observe in the sketch here. So this is the force point which is acting. So here you are applying the force. You are applying the force from your hand, and this is the reference point. So this is a reference point, and this is a distance between your hand, means wherever you are applying the force, and this is the fixed point. So in order to turn this screw, so you need to put some force F from that of your hand so that this screw tightens or it loosens. So for that, this D is the perpendicular distance between the applied force and then the point of reference. This is a point of reference, this is the point of reference, and this is a point where you are going to apply the load. So that perpendicular distance between the point of reference and between the point of application of load is called as moment arm, So always moment is directly proportional to the perpendicular distance, or it is also called as momentum. So moment magnitude of the moment is always directly proportional to the moment arm. So therefore the moment is the product of force and the perpendicular distance from the point of application of force and the reference point for the calculation of the moment. So M is equal to F into D, where M is the moment acting, F is the force acting, and D is the moment arm or the perpendicular distance. So always the SI units for the calculation of the moment is in terms of kilonewton meter, means if at all the force is in kilonewton and distance is in meters, then m will be in terms of kilonewton meter. If it is in terms of newton, force is in terms of newton and momentum is in terms of meter, newton meter will be the unit of moment. Likewise newton mm or kg meter, likewise it holds good with reference to the respective SI units of force and momentum. So this is a basic important principle of the moments. So when the force acting, the principle of the moment always tells for the balance of a moment. For a balance of a moment, suppose you have a force in two directions, so which is of equal in magnitude. Means suppose if you have 5 kilonewton in left hand side and same 5 kilonewton in right hand side. So here you can just observe the two persons are standing here. So this person weight is around 80 kgs and the same 80 kgs holds good for the other person also. So then the distance between this pivot and the left side person is around 2 meters, say for example, and this side is also 2 meters. Then what happens is that there is a balance in the force also. There is equilibrium of forces, magnitude as well as the distance from the pivot point. So therefore in that cases what happens, the resultant of the force will be equal to 0. The resultant of the force will be equal to 0. So when there is no resultant of the force, then what happens, as we know that by the definition of the moment in the mechanics in the previous slide, it is nothing but force into perpendicular distance. If the resultant force is equal to 0, 0 into some distance will be equal to 0 itself. So therefore the turning moment will be equal to 0. So in such case it will be called as balance in moments or equilibrium of moments. So it is totally called as balance of moments, wherein the clockwise moments is equal to anti-clockwise moments. So how do you call the moments as clockwise or anti-clockwise? So in that case you can just observe here in the first sketch, so the force is acting along this direction. So this is the reference point. So you need to calculate the moment about the pivot point, means the force into this is the distance, perpendicular distance. So we need to go along the force through the line of action and pass through the reference point. So therefore it is a clockwise direction. Likewise that will be a clockwise moment. Likewise the force is acting along this direction. The perpendicular distance towards the reference point with reference to this force is in this direction. So the go along this force through the line of action and touch the pivot point. So it is an anti-clockwise movement. So clockwise and anti-clockwise movement. So this is the anti-clockwise movement and this is the clockwise movement. At exactly at the reference point it cancels each other so that it will be in a balanced state. And the seesaw which you are seeing in the second sketch, it will be in the same intact position. So therefore that states the balance of the moment. So in order to have the better understanding of the concept of moments, so I have a numerical over here, so wherein there are four force system of forces. So here I need to calculate what is the moment about the reference point EA. So I have four force system. So here from if I just start from point D, the force acting at point D is 10 Newton. So 10 Newton. So the perpendicular distance between the D to A, why A? Because it is asked for the reference point to calculate the moment as A itself. So the distance, the momentum will be equal to 3 plus 2 plus 1. So it is 6 meters. So I need to go along the force of 10 Newton and through the line of action of 6 meter touch the point A. So it is the clockwise movement. So hence it is taken as positive. So next, likewise, so I have one more force as 5 Newton at point C. So 5 Newton and the perpendicular distance is 3 meter from A to C. So 5 go along the force through the line of action, that is 3 meters, touch the point A. So it is anti-clockwise movement. So therefore it is negative. 5 into 3 is minus 15 and the unit is in Newton meter. Force is in Newton and the distance is in meter. So it is in Newton meter. So likewise, I have one more force, 4 Newton and the perpendicular distance is 2. Go along this force through 2 meter point, touch the point A. It is clockwise. So 4 into 2, 8 meters. So it is a positive moment. So it is a clockwise moment. So last one is I have the force on A itself, but the reference point is the same point. Therefore, the perpendicular distance will be equal to 0. The moment on the same point where the reference point is same, then the perpendicular distance is 0. So total moment of 10 Newton acting on the point A due to the reference point A, it is equal to 0 itself. So therefore, total moment is summation of these moments, 60 minus 15 plus 8 plus 0. So therefore it is equal to 53 Newton meter, which is a positive moment. So therefore it is in clockwise direction. So always the clockwise moments are considered to be positive and anti-clockwise moments are considered to be negative. Thank you for watching. Please like, share and subscribe the videos. Thank you.